Swayam Prabha. Digital India. Educated India.
Hello everybody. Today we are going to discuss very important aspect of vacuum technology within the module 6, where we are discussing design and troubleshooting of vacuum systems. Finally, it is the trouble which has to be handled first in any technology. If you cannot handle the trouble, your industry will go down and that products will not be sold. So, everything will run into problems. So, it is very important for you to know the troubles in vacuum systems and how to shoot the troubles, because these are intricately related to the design of vacuum systems. You should design in such a way, if something goes wrong, you should be able to troubleshoot it. That is why this module is named as design and troubleshooting of vacuum systems. Within that, in the last class, we have already discussed a most important troubles, namely leak detection, and little bit we mentioned about residual gas analysis. These two are related in a way, we will see as time passes. So, present topic is magnetic deflection leak detector and quadrupole residual gas analyzer. Okay. Within this, what we are going to cover? We will introduce you initially about leak detection and residual gas analysis, while we concentrate more on the actual instruments, because these things will come again and again in every application. If something goes wrong or air leakage, sometimes in process industries they will tell, but that is an intentional leakage in the process control when they introduce gases. So, these are all interrelated concepts, and when you introduce some gas, residual gas changes. So, same residual gas analyzer which is going to tell the problem in the system, it can be a useful tool to know the chemistry of the residual gas. So, that way initial days of vacuum technology, these things are designed to solve the problem of getting better and better vacuum. Now, these things are taken in a different shape. For example, partial pressure measurement. Now, we are not that much interested in partial pressure instrument nowadays. Olden days, pressure measurement, partial pressure measurement, these are all very important concepts. Right now, if there is a trouble, vacuum is not coming, leaks are there or outgassing is there. How do we know? RGA shows outgassing, leak detector shows immediately leaks. Solve it, then go to the process, adjust the process parameters and use the RGA to know the chemistry under that operating conditions. Like that, same leak detector, you instead of locked mode of detecting to a particular tracer gas, you try to scan it, then immediately you will get spectrum. This original definition of partial pressure measurements, it is same as spectrum of residual gas analysis, and if you lock something, it becomes leak detector. So, these are all interrelated. As time passes, we will again explain you, because it will be little confusing even for scholars in our lab, they get little confused, because old books have got partial pressure measurement, then somebody says mass spectrometric leak detectors, somebody says only mass spectrometers, somebody says residual gas analyzer, somebody says quadrupole mass spectrometry for vacuum systems. So, these are tools as well as troubleshooters. So, this I want all of you to keep in mind, and working principles of these two important equipment of magnetic deflection mass spectrometer and quadrupole mass spectrometer for understanding possible leaks and solving them to get better vacuum, as well as understanding the residual gas analysis. It may be intentional or it may be background residual gas analysis, or to know the acceptability of that residual gas content to start your application process. So, this is a very important aspect. Finally, we will give you some conclusions based on the instruments. So, in this talk I will talk more about instruments. So, as I told you already, there is a difference between leak detection and residual gas analysis. But actually, if you see a overall broad spectrum, it is nothing but residual gas analyzer. If you lock the scan to only a particular gas, tracer gas with which we are trying to detect the leak, then it becomes leak detector. Leak detector will not become residual gas analyzer, but residual gas analyzer will become leak detector. In a way, residual gas analyzer is nothing but leak detector tuned to various gases. Okay. That way you can think of it. So, coming to the instrumentation aspects of it, let us see. In a typical vacuum system, what is it we are trying to do? Carefully concentrate on this diagram. This is the vacuum system to be tested for leak as well as RGA. Because some problem was there, it was not properly working. So, we are sending it to repairing section. What they will do? This is a high vacuum system and that is connected to a leak detector. It can be magnetic deflection mass spectrometer MDMS or quadrupole mass spectrometer. And it has got modern displays and monitors and IoT, all sorts of instrumentations are there now with digital instrument. That is always there, data acquisition, varieties of instruments will be there to help you anyway. Okay. Now, this is connected to a high vacuum pump. Why? These detectors need vacuum for their operation. They are used to troubleshoot a system, vacuum system, but they themselves require vacuum. It is like cryogenic engineering. Cryogenic engineering requires vacuum, otherwise you will not get low temperatures, but cryogenic engineering can produce best vacuum in the world. So, like that in nature you will get such coincidences. Okay. So, you require a high vacuum pump backed by a backing pump, but I am putting a wall here, we will tell you later why. I have put another wall here, I have put another wall here. This is somewhat similar to our diffusion pump, but only the context is different. Same backing pump can be used by opening this wall and closing this wall to rough the vacuum system, the way we explained you in diffusion pump. But during that roughing, this throttle wall will be closed, this backing wall will be closed. If high vacuum pump was running earlier, let it run also under no load conditions. After all, detector is a small box and it is a leak tight anyway, and these are electrical feed through connections. So, this is not a part of the vacuum system. So, these things are already in good vacuum and these two walls are totally isolating the leak detector part of it from the rest of the system. And this backing pump, which was originally backing of the detector vacuum pump, it can also be used to evacuate if this volume is smaller, because the vacuum pumping system attached to detector is relatively a small pumping system, but high vacuum. It is also having a turbomolecular pump, it is also having background dry pumper or rotary pump, but capacities are not much. Its purpose is to keep the detector in good vacuum condition, but you can use this to rough it provided if the system is small. When that will happen? Component testings. If a company is regularly manufacturing components, one by one you keep test it. But if the system itself is too big, 20 times bigger than the entire volume occupied by all these things, then it will take a lot of time and these will be overloaded pumps. So, what we will do at that time? We will put an auxiliary vacuum pump to evacuate to -2 torr with this valve open. After getting -2 torr, you do not need high vacuum pump here, because 99.99% of the gas is removed and oxygen, water vapor and all can be handled by this pump. Now, it is a dry thing, and from -2 to -5, even though it is a large system, it can be handled by these pumps, and during that time -2 should be further improved to -5. No need. For leak detection time, let it be -2. So, that means you close this wall, you close this wall, and if there is some more problems or heavy leaks etc., keep running this also, no problem. But this valve should be opened at that time, and during that time roughing valve should be closed. That means, this vacuum pump is dedicated to maintenance of vacuum in the detector. This vacuum pump is related to maintain against all possible problems of a -2 torr. From -2 to -5 torr, if throttle valve is there, it can withstand high pressure drop naturally, and a signature of this gas chemically can be felt when this valve is opened. The proportionality constants can be adjusted in the calibration constants. This has to be done. How do we do it? You can put a standard leak here and calibrate it, and then use this. Under these conditions of volume, how the standard leaks will work, because that get distributed using that equilibrium pressure it leaks, all that is a big field by itself. If you are interested, later you approach me, we will explain you, because it requires quite a good amount of knowledge in various other aspects of vacuum technology, like outgassing and leak rates etc. Okay. So, this is how the entire structure looks like in the leak detection or troubleshooting equipment. And as I told you in the last class, a test gas helium, because it is the smallest particle, it can leak through various things, fine leaks also we can test it, and helium is rarely available. So, that only when you trace it, the detector which is tuned to this particular helium gas will detect it. Otherwise, it will be detecting, if it is tuned to nitrogen, even though we do not trace it, we do not know how to locate it, there will be leaks from everywhere, and this will be continuously giving signals. Normally, even though the system is -2 torr, even though there are leaks, if unless you trace the gas, the mass spectrometer detector shows 0. That means, partial pressure of helium is 0. So, leak is there, but leak is not traced. Leak is there was told by the original system manufacturers, because when they are applying, they are not getting vacuum, they have sent it to the workshop. Now, we are testing it, but that testing need not be done under high vacuum, -2 torr maintained by this. I hope things are very clear, but this particular discussion I am talking, normally we take 1 hour 2 hours time to explain all these sub blocks, but you will be able to understand if you again hear my introduction slowly. Okay. Now, what is this detector? In a simple layman's language, I am concentrating on detector part of it, not vacuum side and stuff. Some molecules are detected from here to inside molecules, and these molecules are coming from the outer side because there is a leak. So, this leak we want to identify what is the rate of leak and whether what is the location of leak. That is the application, but how the detector works, these leaked atoms will come inside and we are tracing it, and we are lucky to get the leak anyway. So, the leaked elements are helium. So, these are helium atoms now. If the tracing is not done, these will be general atoms, air atoms, but once tracing is done, this will be flooded mostly with the helium gas now, like a purging. This helium gas at -2 torr, partly it goes here, partly through the throttle valve it will go here. Once it goes there, their atoms, they can be ionized by high speed electrons emitted from a hot filament and accelerated to a electrode, and immediately they will be ionized. That is called ionization chamber. These ions will be sent or throttled through an orifice into another chamber, where they will be accelerated, and we will adjust electric and magnetic fields in such a way a constant velocity is selected for all the ions. It is possible by suitable mass, I can show you later, but right now because of lack of time, you assume that all the ions will be having similar velocity, because here some atoms are maybe going air atoms, some helium atoms, we do not know. Now, all of them are accelerated. So, all the ions will come here, but different ions will be deflected in different orbits if there is a magnetic field. This is a permanent magnetic field, 90-degree bending magnetic field. So, ions are produced, ions are accelerated, ions are collimated, and it contains mixture of ions. If you are tracing it, it will be rich in helium, that is okay, but other ions also will be there. Heavy ions will be deflected in a very wider path radius, and very small ions can be deflected very much because Lorentz force is very high. A particular helium ion can be deflected here. Like that, we will have to adjust the parameters of voltages and magnetic fields. Then you keep a small opening and that ion collector will collect only helium gas. Instead of keeping it here, if the ion collector is kept here and make a hole here, it will measure hydrogen. If you keep it here, it will measure argon. But in the leak detector mode, we will keep it to helium because we are tracing it with helium. If it is a residual gas analysis, this will be shifted everywhere and no tracing is happening there. Okay. So, the same thing can be used to get an RGS spectrum, or if you lock it to helium, you will get a leak detection because all other gas molecules will not be coming through this and cannot be collected by this ion collector. This is one instrument called magnetic deflection mass spectrometer. Similar instrument, instead of using permanent magnetic fields, you can use quadrupole instrument. That means 4 rods forming a quadrupole. Quadrupoles are very famous in nuclear engineering, and again electrons are there to accelerate, it produces ions, ions are collimated and all the ions will be going just like here, but this time there is no magnetic field, there is a RF and DC fields applied to this 4 rod structure. That means there is one DC field, there is one RF field acting on this quadrupole. These alternative rods are short circuited. So, these are applied parallelly with 2 sources, one later we will see one DC field and RF field. Under those conditions, a particular ion depending on the fields and voltages will be able to cross this path filter and gets connected. We will tune those parameters in such a way helium will be crossing. This also will be in leak detector mode. If you do not tune it, by scanning these voltages, you can tune it to various gases at various timings. If you do that, you will get a scanned output like this, which is the residual gas spectrum like this. If you do not tune it here, the voltages, and if you do not tune this position or respective parameters, then both of them can be used as a leak detectors. So, commercial helium based leak detectors are available in magnetic deflection mass spectrometer and quadrupole mass spectrometer. If they are locked to helium, they can be used to find the leaks. If they are not locked, they will produce the spectrum, and it can be 0 to 200 AMU, which is very useful tool in semiconductor technology, because which gases we are doing, under what conditions we are growing this chip, we have to very important. That time this is not a troubleshooter, this is the actual chemical signature. Okay, this is a friend. Friend in need is troubleshooter, a friend routine friend, because the residual gas is analyzed like that. So, residual gas analysis and leak detection can be done by the same instruments, and such commercial instruments are available, leak detectors and residual gas analyzers. These are quadrupoles, quadrupole mass spectrometer, this is a magnetic deflections. Here there is no magnet, here RF fields will be there, here DC fields will be there, as well as magnetic fields will be there. So, little more in detail physics of it, those who are interested. This is the typical deflection magnetic mass spectrometer. Do not worry too much about the structural things, if you carefully observe, after some time you will understand. It is nothing but a source of electrons in a filament, you apply a small voltage to heat it, thermionic emission electrons will come out, and that is the power source for this, and these things will ionize all the atoms which are around, and because the entire equipment is under vacuum chamber, it is only a zoomed version of the instrument. This is whole thing is the detector, it is integrated with the vacuum system which we are trying to analyze. So, that way it is a part of the vacuum system. So, ions are created because these electrons are accelerated, they are getting high velocity, they ionize it. Once these ions are created, they are coming out with constant voltage selectors, velocity selectors, they are all there as a part of this magic box, and later when it goes to these electrodes which are maintained at a high voltage here with respect to grounded electrode, because of this these are accelerated, electric field is there, as well as magnetic field is applied perpendicular to the entire structure. So, cross electric and magnetic fields will create different ions with different charge to mass ratio. Helium can be helium plus, helium 2 plus. The way helium 2 plus bends will be helium plus, because this plus or 2 plus is interacting with the electric fields. At the same time, the current is also interacting with magnetic field through Lorentz forces. So, all this together we will see in the figure, they will be going into various orbits different depending on their E by M ratio. We adjust it assuming mostly all of them will be singly ionized states. So, helium ion will go through a small slit without touching this grounded electrode, it will come out. This is a 180-degree deflection type because of electric and magnetic fields available, and it will reach another slit here and go to the target where it will be charging a particular thing, Faraday cup, and there are so many detectors that will be amplified, and that signal is proportional to number of helium ions entering here, that is proportional to helium atoms, that is proportional to sprayed helium that we are suspected leaks we are spreading, that is proportional to leak rate. And if you do not spray, we are using various things, then what to do? We will adjust the voltages so that sometime this ion will enter, sometime this ion will enter, you will get a spectrum. So, I am showing it in the line diagram here, ion source, accelerating voltages through slit, it will come a particular ion where the orbit is matching to the helium, for example, it will go through this, escape to these two slits and finally get collected with a DC amplifier to give a signal proportional to the partial pressure or content amount. Okay. In our case, it can be leak detection or residual gas, and we kept on scanning these voltages so that this slit will be coming into stable path for different ions for different voltages. In magnetic deflection magnetometers, we can do it by adjusting certain voltages because permanent magnets are there. In quadrupole mass spectrometers, we can adjust RF voltages and DC voltages, and then also stable paths can be created. There is no magnetic field, that we will see in the next slide. So, when the mass spectrometer is used in the leak detection, a singly ionized state, it is stabilized because this slit is calibrated only for helium. And what is the mathematics? For an orbit, there is a centrifugal force for an ion having a mass m, mv square by r. There is a Lorentz force B cross I type NeV, this V is the velocity, E is the charge carrier. For singly ionized thing, n will be 1, otherwise it will be 2. And where is this velocity coming? That is also coming from the applied voltage, electric voltage. So, half mv square, the kinetic energy of it is coming from NeV. Okay. That Ne is the charge element, singly ionized or doubly ionized, and it is accelerated by a voltage V, that is the electrostatic force, electromotive force. That force is equivalent to centrifugal, half mv square is the kinetic energy. This is energy, sorry, electron volts, this is the energy. Here this is a force balance, here it is the energy balance. From this energy balance you can know the velocities and substitute here, then you will get another equation where B square is the magnetic field square, r is the radius of that orbit for a particular charge carrier, whether it is helium ion or this one, V is the applied voltage and m is the mass of that charge carrier. So, this equation you can easily derive from these two equations. So, if you scan, all the entire thing is constant for a particular B, particular R, particular charge, these are constant. So, you can say the the voltage is inversely proportional to the mass. So, if you keep on scanning V, you can get mass spectrum, and if you lock it to helium, you will get leak detection. This is the principle of helium leak detector used as leak detector, and if you do scanning, it is variable voltage. But things are little more easier when it is quadrupole mass spectrometry. Analysis is difficult, but it is easy because here magnetic fields are there, magnets in the vacuum chamber are not good also sometimes, but of course magnetic fields can be applied. The making it in line with the gas particles flow via detector will be little difficult, and this purpose is for helium detectors mostly. This is a high sensitive detectors. Quadrupole mass spectrometers are purpose is residual gas analysis, but locking it you can use it for leak detector, sensitivity will be less. That is what we will discuss in the next slide. Here this is another instrument, this whole lecture is on instrumentation aspects. 4 rods are there as I explained you already in the first slide, and again we have got ion source. I am not talking about electrons, accelerations, ions, ionization, all that is built in this magic box. These ions, this entire instrument is built within the vacuum system. The ions are now collimated through a slit, through an orifice, and all the ions will be going through a filter called quadrupole filter, and there will be one DC voltage and RF voltage applied to the pairs. Each 2 electrodes is 1 electrode, plus plus minus minus, because these are short circuited, these 2 are short circuited, vertical things are short circuited, horizontal short circuited. So, only 2 element in the across those 2 elements parallel circuit, DC voltage, RF voltage. So, I have just zoomed that here. So, this way when you adjust these DC voltages, keeping DC by RF potentials constant, why and all I will explain little later, you will get stable path of ions for various voltages to various masses. Stable means, because when these particles ions are coming here, there is an RF voltage which is oscillatory. So, ions will oscillate, smaller ions will oscillate bigger ions they will be connected to DC field and RF field, they may be very sluggish. So, sluggishness, oscillations, there is a competition, a particular ion for which all these things are matching, the oscillations are not reaching to the radius or gap between these two. By the time it wants to go up, already RF voltage has reversed, such things happen. So, that particular fellow keep on oscillating and not sluggish enough to fall into any electrode and get short circuited, it will be able to pass through this. Okay. Once it is passing through this, it will go to the detector. There are varieties of detectors which will detect the amount of charge getting collected here, that is proportional to that particular ion. So, when you scan these voltages, you will bring various ions into stable paths. So, that way by changing the RF voltage and making the RF voltage to the DC voltage ratio to 0.167, it can be connected in a vacuum system below 10 power minus 5 torr. In such a way, you can utilize it to get the chemical signature of the residual vacuum, that is called residual gas analysis. So, this instrument can nicely be used to get a spectrum like this. What is this spectrum? This is the mass number that is changing. Okay. These two are spectrums. The mass number is changed, and that means several ions are brought into the focus by adjusting RF voltages, and the current here is the y axis, that is calibrated in terms of partial pressure, because when you add all these partial pressures, you will get total pressure. Total pressure can be measured by a Bayard-Alpert gauge. If that is this much x, and if the heights ratios if you know properly, because all the heights if we add, that will be some amount. So, that ratio if you take height of each peak divided by total heights, that will be the ratio. If you multiply that ratio with the total pressure, you will get partial pressures. So, it is equivalent to the quantity of various gases available in that already evacuated residual gas. So, that is why it is a chemical signature of residual gas spectrum. Here how it is useful to us? Here is very useful, because in a baked system you will see there is a blue color. That means, as soon as you bake, all the heights are falling down, relative heights may fall down, certain things might have gone, certain things might not have gone. It is impossible to remove moisture because they are polar molecules. Certain things are very easy, certain things are light molecules, they would like to be removed, but somehow it gets caught because conductance is poor for them. So, for the same pipe, so conductance also depends on mass. So, things like that. So, you will get baked system, unbaked system, two spectrums. From that you can understand very nicely the problems associated with the vacuum system. This is one way of troubleshooting chemically. Another way of troubleshooting is you can link it to a particular mass. That means, same spectrum, you do not scan it, you link it to helium, then this entire spectrum it is stable always only with that, then you can measure leak detector. Of course, this is not as sensitive as mass spectrometric deflection magnetometer using magnetic field. This is highly sensitive. This can do leak detection more efficiently and residual gas analysis less efficiently, whereas this can do residual gas analysis more efficiently and leak detection little less, but good enough to locate the leaks. but exact amount of leak rate if you want to measure, you should go for this type of leak detectors. Okay. And these are shown also earlier. This is my deflection type of leak detector, I totally dedicated for leak detection only. This is dedicated for residual gas analysis. By locking it to helium, you can use it as a leak detector mode. So, a special mode cannot be a very sensitive mode. So, you have to keep both these instruments in the laboratory as an essential accessories. So, this is how it looks like. So, all that we need to do is a spectrum obtained by RF and DC voltages, bringing various ions having various E by M ratios into focus. They will oscillate, but they will not be collected to this quadrupole field, they will be escaping finally, and these are solutions of Matthews equations, differential equations with the force functions. You will have a lot of you can find it in the internet how these various paths are getting stabilized. A lot of mathematics is there, very interesting mathematics. It is not a difficult mathematics, interesting mathematics. I request all of you to go into that, because engineers also should know some maths. Okay. So, that way it will be quite challenging. Now, coming to the picture here, there is a typical residual gas spectrum. So, when you are coating a semiconductor, you know under these conditions I have coated, you can tell. Tomorrow the reliability of the device is not coming, then you do not know how to interpret. It is like a black box of a aeroplane when accident takes place. So, from the RGA you can understand, oh, that day the peaks of silane is not much, this is not much, hydrocarbons are there, they are interfering, p type is more, n type is more, you can understand. That way RGA will be very useful for you. Similarly, in chemical industries or pharmaceutical industries, that is not properly acting. So, you may say that, oh, apart from this ibuprofen, some other signal has come out there, some other chemical things have entered there. So, that is not working properly. All this on the spot monitoring can be done using this residual gas analyzer as a very useful tool to know the chemistry, to use it as a troubleshooter, as well as to understand the black box type of management when something goes wrong. I hope things are somewhat clear to you, but it is a very big field, because a lot of instrumentation is there. Now, automation is there, IoT is coming in a way, they are continuously upgraded, commercially available. So, I request all of you to go through these things in the internet, where a lot of articles are there. So, to conclude, the leak detectors and residual gas analyzers are most essential equipments in a sophisticated vacuum laboratory or industry, particularly high vacuum and ultra high vacuum. From the leak rate measurements, you can easily understand the quality of the chamber, quality of the component, and once you know the leak rate, once you know the pumping speed, ultimate vacuum can be easily worked out using the standard law. This Q dot total is pumping speed into equilibrium pressure, that equilibrium pressure will be ultimate vacuum. Okay. If it is not acceptable, solve the leak, such decisions can be taken. Or it may be degassing problem, then RGA will tell it is not leak. So, by connecting both these instruments, you can nicely understand the trouble also. That is why I have included it in the troubleshooting, but later in the application areas I will introduce it as a chemical signature of the process going on. Okay. We will see that. So, residual gas analysis is also useful in contamination in the semiconductor issue, vapor contents, water contents, etc. That way it is used in CVD and high vacuum molecular beam epitaxy, etc. So, that you will know, am I coating properly or something else is coming. Quality control can be done, and leak detectors, filaments have to be replaced now and then. So, the engineer should keep sufficient spares of these things, and he should know how to troubleshoot the leak detector, so that the leak detector will troubleshoot his vacuum systems, so that his boss is happy and he will get promotions. That way leak detector and RGA are most essential equipment in sophisticated vacuum process industries. With this idea, with this instrumentation details, thank you very much.